My name is Dick Hopkins. I'm a generalist with experience in many things forestry. I do have research experience in microclimatology in the Ross Lake Basin, forest hydrology with Champion in Voigt Creek and Winston Creek, and I began some investigation of root rot with Champion at Kiona and Voigt Creek, if you know where those places are. So we want to talk about the addition of potassium to Douglas-fir seedlings with associated laminated root rot. And the current scientific name for that is Felina sulfuracens. Back 40, 50 years ago, you may have heard this root rot. It is a natural fungus called Poria wirii. In 1974, the genus name was changed to Felina wirii. And in 2005, through DNA research, scientists distinguished that there was a difference between the Felinas found in Idaho and the west slope of the Rockies and the Felinas that we have here on the west of the Cascades. And so the Felina wirii in Idaho kills western red cedar. The Felina sulfuracens that we have here in western Washington and Oregon primarily attacks Douglas-fir and grand fir. And western red cedar here is resistant to it. So depending on location, you can have different outcomes of what is killed. So I have 20 years of research in a file cabinet, and I think that's a waste of resources and time and ideas to leave it locked up in a file cabinet. So decided to put this presentation together. The work was conducted both at Green River Community College and at Lincoln Tree Farm. And Lincoln Tree Farm is owned by Tacoma Schools. So Felina sulfuracens or laminated root rot delaminates the annual rings, as you can see in this slide. It basically tears the root structure and even the lower portion of the heartwood apart in the trees. Laminated root rot shows symptoms from the top down. The trees begin dying from the top down, but there's many other things that have that symptom as well. So it takes some Pulaski work at the roots to figure out what you really have. When we do have laminated root rot, there are a few roots that are left intact to hold up the tree. You may have just a few laterals, but the taproot is typically gone. So in 2000, the forest protection class at Green River Community College, which is now Green River College in Auburn, studied forest health in the DNR-owned school forest. And we invited the DNR forest pathologist, Dan Umdahl, to attend a presentation. And we pointed out the number of dead trees in the forest to him. So Dan Umdahl proposed adding potassium to the soil to change the root chemistry to lessen the susceptibility of Douglas-fir to laminated root rot. So the idea is kind of like you take vitamin C to hopefully ward off a cold. And there had been successful research done in agriculture by adding potassium to the soil in some agricultural products. So the spring of 2001, we began an initial trial plot around a down Douglas-fir. And you can see the stump there. Gene Burns with the Washington Department of Natural Resources is on the left, one of Dan Umdahl's assistants at the time. And this plot was named Jeannie's plot. We named every plot for a student to help them gain ownership of what was going on. The seedlings on this initial plot, this was basically a beta trial, were planted at 2-foot spacing in a 1/20th acre plot. So you can see they're 2 by 2 down there. And then we added 4 pounds of potassium to the inner 1/100th acre, which is just short of a 12-foot radius. So this is Martin Greenhaw. He's now one of the partners in Timberline Silvix in Snoqualmie. And potassium was in the form of potassium chloride, or KCl, also called muriate of potash. The bags came in 50-pound commodities, and but we weren't using very much to begin with. And we obtained this from Wilbur Ellis Company in Auburn. They were the suppliers. So in 2002, a year later, Jeannie's plot is weeded and tagged and measured and recorded. And one of the primary things that we wanted to look at here, we had thinning in mind into the future. And we needed a beta plot to test how we were going to thin. We proposed a formal research project with forest practice application, the whole dozen pages, to use 21 plots. So we had 21 plots. 7 of those were control plots with no application. 7 of those had 2 pounds of potassium per plot, and 7 of those had 4 pounds per plot. So scattered in a relatively close area in the Green River School Forest. This is what the school forest looked like. It was a tangled mess of vine, maple, hazel, ferns, devil's club, and big old dying trees. This is Ron Larson, a faller from Alder, that is starting to take down the dead trees that we were going to put the plots around, as well as hazard trees. We didn't want standing dead trees in the research area that could come down and cause more problems, especially to students. So we did fall 21 trees. The plot numbers, if you noticed, went through plot number 22. We initially rejected plot 16. So there's not a plot 16, but you can see the stain and the rot in this big stump after the tree was felled. We calculated inoculum indices, and that calculation in a table form looks like this. And basically, I'm just trying to show you how what we did. So we have the 21 stump numbers. We have the DBH. We made comments of what they looked like, how long we thought they had been dead. There was some calculations done by someone smarter than me, and came up with an inoculum index on the far right column. And that gave us a hint of, or at least a map of what we thought each plot should have, whether it would best be served as a control or a 2-pound plot or a 4-pound plot. So after falling the trees and bucking numerous windfalls that were already in there, we brought in an excavator and began clearing and piling the brush. And you can see that it was almost impossible, well, impassable to try to walk through the parts of the school forest before we brought the machine in. So we worked every plot from the outside with the excavator, and we took care not to disturb what was in the ground. We actually did handwork to remove what we didn't want the excavator to disturb. So this is plot 1. We were concerned that we might get vandalism or mischief. So we put together signs that basically described what we were doing. We also did what we called walkabouts with students and faculty and neighbors. We had walkabouts on Saturdays to explain what our process was and what we hope to accomplish. Pam Phillips here helping hand clearing. This is plot 2. So each plot was planted within a 1/100th acre circle. In other words, 11.78 foot radius with Douglas-fir. And we planted outside of that with other species. We planted cedar, we planted hemlock, we planted, a couple of students planted sequoia and redwood. So we tried some other species that we thought were less susceptible to the root rot. We took soil samples. There had been, previous to this, 2 other studies conducted in Western Washington. Richard Miller with Pacific Northwest Research Station and Walt Thies, also with the research station, in Portland, had done studies. Miller's was at Voigt Creek near Ording, and Thies' study was, south of Randall in the Kiona area. And so we wanted to eliminate as many variables as we could and try to have very specific data on everything. So we did obtain soil samples. Nick and Diane here. This is an Everett, very gravelly, sandy loam. The site index here was 110. So Melanie with the Washington Department of Natural Resources gathering the soil samples and maybe telling a story and making the students laugh. So we analyzed sugars, phenols, tannins, and nutrients, both in the roots and in the needles. And each of the trees within the 21 plots were tagged and measured. And so Carly had her plot and Brandon had his plot. And through the silviculture classes that followed, each student was assigned a plot to take care of. Wayland and Pam here. We designed templates that we put on top of the center stump that fit in the same location every year. We used 18 degrees east declination. And so we could tape from this plot center out where every tree was located and what its azimuth was. We used azimuth, not quadrant. So Rob Sjogren, instructor on the left, and Nick with his back to you. And Carlene is in the upper right and Leslie down below. Typical sunny days in the woods. All of the plots were fertilized on March 26th of 2003. This is Jeannie on plot 22. You can see the tangled mess behind her. And Nora and her boyfriend measuring, monitoring and collecting data. And that continued from the time of fertilization from 2003, essentially through 2013 when I left. The 21 plots were thinned in 2006 to 50 trees. And at that time, we also added 10 new plots. So this is from 2002 to 2006 growth. And this photo, let's see, the thinning was at the end of October, the beginning of November, and basically a month later, we had a windstorm on December 19th. And you can see what it did to the plots. We had 1 or 2 windfalls on almost every plot except 6, I think. So we had to cut the windfalls out. We had to stake the seedlings back up. We actually were able to salvage the research for the most part. Couple years later, here I am in 2009 on plot 2 with one of the interpretive signs on that tree with, looks like, oh, it's moss or lichens. That's not ivy. Here's Dan Umdahl in May of 2013 examining the second of the thinned removals. So we did removals, and the way that we determined whether a seedling had root rot or armillaria or some other problem was by actually pulling up the dead trees, and Dan or his assistant would examine every tree, and we recorded what the result was for every tree. Now, this is the results of the 2013 report that we did. And Paula Hopkins accumulated the numbers, and Amy Ramsey, who was assisting Dan Umdahl at the time, put the graphs together. So in the top, well, in all 3 boxes, you can see green is control, blue is 200 pounds per acre equivalent, and the orange is 400 pounds per acre equivalent. In the top box, we have the average percent of Felinus caused Douglas-fir mortality by treatment. So you can see in the top box, over the 10 years, adding more potassium reduced the mortality in the Douglas-fir seedlings through that 10 years of growth. In the middle, we have the average percent of all Doug-fir mortality by Felinus, by armillaria root disease, and other causes. So you can see 200 pounds per acre actually does better on all of the other problems that we have. And what I think is very interesting is the third box. The average percent of Felinus incidence, the incidence in Douglas-fir by treatment, by examining the roots of the trees that we pulled. So there again, you can see 200 pounds per acre, a lesser amount than the 400 pounds, did an adequate job, or at least a relatively good job of reducing the incidence, and comparing back to box number 1, the mortality of the Felinus. Okay, so let's move to Lincoln Tree Farm. Lincoln Tree Farm is American Tree Farm certified. It's Washington number 3281. And if there's any tree farm inspectors out there, we need to be looked at again. Time is due. So at Lincoln Tree Farm, Highway 7 is to your left or to the west. The compounds and the classroom buildings located in the southwest. And just to the east of that, we had a 6.5 acre research area. And then we also had what we called the acre, which had additional plots up near the power lines. This is Bonneville power lines running through the property. So in this case, we tried 36 1/300th acre plots. We were trying to get those seedlings as close to the stumps as we could, and actually try to infect the seedlings from the stumps that had been identified with laminated root rot. So here's plots 28 and 29. And I'll say when we had 2 plots close together like this, we applied the same the same application. So these 2 plots had 200 pound per acre equivalent. So here's 2014, and here's January of this year. So 200 pounds per acre equivalent on those 2 plots I just showed you. And you can see there's a noble fir in front of me. We did plant some other species around the plots as well. Here's an example of the potassium chloride. It's very small, granular, and made in Canada. And again, we obtained this from Wilbur Ellis in Auburn. This is an early photo of the daylight unit. And we discovered, you can see the honey colored mushrooms. That is armillaria. And if the Felinus doesn't kill them, the armillaria can take them out. So plot 15. You can see a lot of brush, grass. This unit was site prep sprayed, and we also did a release spray 2 years after that, I believe, for the grass. But we had just tremendous problems with drought. 4 years of drought, 2014 through 2018. This is plot 17. And you can see there's a lot of trees that died from drought. And this is a 400 pound per acre equivalent. You can see Bonneville power lines in the background there. This is plot 8 last month. It is a control, and it is up against the timber and in a little better position than the previous plot I showed you relative to drought problems. Here we have plots 1, 2, 3, 34, 35 a month ago, and you can see the grass, which just robs the trees of moisture in the droughty summers that we've had. This is a slight west aspect. whereas where we had the big problems with drought was on the flat to the right of this photo. Okay, this is a unit of 2013 harvest and planted, and we broadcast applied 200 pounds per acre for 7 years. So this is 7-year-old growth, and you can see that it looks pretty good. I will admit that just after this photo was taken, I ran 2 strips through this unit, and there are some small holes. What's interesting is it got so thick trying to walk through this plantation with a spreader on that we gave up basically 18 months ago. And in those 18 months, we have started to have mortality, not in these big 25-foot tall trees, but in the medium-sized 12, 15, 18-foot trees. Not a lot, but some. This is the spreader that you hook onto the front of you for broadcast application. 50-pound bags. We split a bag 25 pounds per trip, and we've gotten it down so that we know what setting on the spreader will give us the 200 pound per acre application. It took some trial, but we figured it out. So other options. I want to present other options besides using potassium. So you could split the stumps with an excavator. This is the Academy unit as it was being harvested. We also used an excavator to pull the stumps up and pile them. This is the Academy unit taken last month. So you don't see any orange trees out there that are dying. There's some yellow, but we typically get yellow coloration in the winter. So we're not concerned, and this plantation looks pretty good. For John Page and Terry, this was planted by the Willie Stewart Academy. Tony Lund was the instructor. So another unit that we did, we logged in 2011. We stumped it. You can see the excavator, and over to the side is a stump splitter. So he would grab the stump splitter within the bucket and the arm, and then jam it down through the middle of the stump, which broke it up enough that he could pull it out easily. And we site prepped this unit after the stumps were split, and we burned the slash. So here's the same unit in 2021. And it looks pretty good all the way through. Paula pats herself on the back every time we drive through this unit. Another option is to plant Western red cedar. This is a 2013 plantation, and the photo taken in 2016. You can see that I'm out there amongst the tubes. We used large tubes with long stakes, and this requires annual maintenance of pulling the tubes up and restaking. We have a healthy elk population as well as deer in this area, so we had to protect the seedlings. But from this 2013 plantation, here's what it looks like in 2021. So if you spend time and do the maintenance with those tubes. Eventually, we pulled them off once they got above the height of the elk browse. And again, Paula is very happy with this plantation. We were questioned whether we should plant cedar on this site, and cedar actually is doing better than Doug-fir on the tree farm. Another thing that we're doing, you can see it in the tubes in the background, but this year we are planting Sitka spruce with western red cedar. And you can see the Sitka spruce stem on the right and the cedar stem on the left. Ideally, the spruce is taller than the western red cedar. And so when a deer or elk reaches down and tries to bite the top out of the cedar, it gets a mouthful of Sitka spruce needles, which is the ouch tree. We planted cedar and spruce together some years ago on another plantation. And this past summer, I cut the spruce out. So within these triangles, you can see the top of the western red cedar. This is about an 8-foot tree. This is about a 12-footer. There's about a 10-footer in the background here. And so we left the prickly Sitka spruce around the bottom of the cedar. And now the cedar are free to grow and not being bothered by the elk. So this only requires one application, coming back with a chainsaw at some point, maybe 6-8 years after initial planting of both species. We've also tried planting a mix of species that are not as susceptible to laminated root rot. You can see we do have a Douglas-fir here, but we planted western white pine in this unit, and all of the alder that you see came in naturally. We have actually pruned the alder up as high as the students can reach and done a little bit of thinning. This alder patch is protected from ice storm and wind damage. And so we've not had any of the typical damage that alder plantations get. We'll wait and see, but this is something else that could be done rather than planting straight Doug-fir in an area that you have laminated root rot. There's always the do nothing option, and you may have to come back and pick things up on a very poor log market, not like the log markets today. But this is an area that blew down with weakened root systems because of laminated root rot. So I would argue that disease can be managed. You can use different alternatives, species. You can take the stumps out to eliminate the root rot that's in the stumps within the ground. The root rot doesn't move within the soil. It moves from root to root contact. And of course, adding the potassium. So back to my favorite photo of how you could broadcast potassium at 200 pounds per acre. We have run the calculations on this, and it averages out on the labor side at $100 per acre, which isn't bad. If you had larger areas and you could get a helicopter, that would cut the costs even more. But as you could see in that one slide where we showed the differences of control versus 200 pounds per acre versus 400 pounds per acre, we think you have to apply this annually. So I'm going to answer Brian Lauk's question. Because he asked me a month ago, well, what if I don't want to pack 3,000 pounds of potassium every year on my 15 acres that I'm going to harvest and I know I have root rot on? So Champion based at Kapowson, north of the Electron Gate, this is the 100 road which goes towards King Creek. Puyallup River is on the left. In 1985, thereabouts, Champion did a lot of stumping. And so this area that I hope you can see my cursor was stumped, and the area over by the river was not stumped. And this is a Pierce County photo of 2 years ago, but you can see the orange and white dying and dead trees within this area that was not stumped. The area that was stumped looks pretty healthy. So even though I'm a proponent of applying potassium, if you don't want to pack 200 pounds per acre every year over acres and acres, and you can't get a helicopter, I think your best, Paula and I both think that your best alternative is to do a one-time stumping with your site preparation and then plant your trees. I will get things changed here and answer questions. Yeah, Donna or Brian asked, some fertilizers can change the pH of the soil. Do you know if there was any pH change in our soil? And we actually measured the pH at Green River in Jeannie's plot before and also in the Felina's test area. And both of those at the time, the pH was 5.6, and following up later did not change the pH. We also measured the phosphorus, the potassium, the organic material, the nitrates, and the ammonium. If you owned a stand with Felina's, what would you do? If it was a small stand and I wanted to get ready for an Ironman competition, I would use potassium at 200 pounds per acre every year, or get a helicopter. But the easier way to do that is obviously to stump, site prep, and then plant. Another question, you mentioned that you chose the treatment levels based on the inoculate or pathogen levels. Can you tell why the treatment plots weren't randomized? They were actually. We did not try to, I guess I wasn't clear on that. We actually did try to randomize based on inoculum levels, so that we had a control, a 2 pound, a 4 pound on similar stumps with the same inoculum levels. So yeah, we did. Do you have to be licensed to get permits? No. You can buy potassium on the open market. We've never had any trouble getting it. It's basically, it's a fertilizer. So, no.
No, you don't. I will add that we do special order this through Wilbur Ellis, and they get this specific for us. And so it probably would be difficult to find, at your local hardware store.
Yeah.
Or, farm supply store. You might need to go to a chemical place to get it. And then I know Wilbur Ellis, you do have to have an account with them in order to purchase any chemicals from them. So there might be some phone calls that you need to make to get it.
Thank you. I'm actually a student at Green River College right now. I'm going into their bachelor's program and we do have to do a capstone. I'm fascinated by Felinus and I'm just starting to really dive into it with silviculture classes. So this is a great resource to kind of start diving into this. So thank you for that information.
Yeah. Unfortunately, in 2014, I think it was, the plots at Green River were destroyed in order to pull up all of the trees and examine all of the root systems within those. And Paula and I were not part of that. We've been able to get some of the results from Dan and his crew, but I did not include anything from that period because I simply wasn't a part of it and had no knowledge, no direct knowledge of what happened. So I'm only accounting for the 10 years that I was there.
Yeah, I'll have to follow up with some of the faculty that are there now because I'd be interested in seeing where this was on campus or just anything else pertaining to it after 2014.
Yeah, Monica and Chuck would know where the plots were. And Jean knows some of what we're doing at Lincoln Tree Farm. So
I will follow up with both of them. I have Chuck in the morning, so.
very good. Say hi to him for us.
I will.
Let's see, other questions? I'm not seeing any. Oh, is the expensive stumping or potassium worth it versus choosing a different species like cedar? Well,
It depends on when you want to harvest.
it is partly up, is your management goals. Right now, log prices for Western red cedar are $2,025 per 1,000 board feet, compared to your highest priced Douglas-fir export log at about $900 per 1,000 board feet. Unfortunately, Western red cedar doesn't grow big in 20 years. So you've got to weigh the 100-year rotation age of Western red cedar to other things. Alder, for example, you could get 2 crops of alder, and alder is resistant. It's not, it is absolutely resistant to this fungus. Any of your hardwoods are. I wouldn't recommend planting maple, but you could do 2 crops of alder where you've got where you have Felinus in the same rotation age as cedar, or in 2/3 the age for Doug-fir. So it's partly your management plan. Paula's got an addition to that.
So when it comes to the expense of stumping, I would say, I think your cost of stumping is going to be less, if not equal to the cost of managing cedar to get it to that 6-foot height out of the elk's reach of eating it. So I think it's just, you know, a matter of your preference of what you want to grow. I love my cedar plantation, but it is very time consuming. And if you do the spruce cedar mix, you're still paying double the cost of planting, even though you don't have the yearly maintenance. So that's something to think about. It is, I don't think it would, over time, I think stumping is going to be cost about the same as if you're going to put cedar in.
And you only have to do it once.
With the stumping, yeah. So Do small forest personal property owners need to worry about root rot?
Yes. We harvested a 2-acre parcel last month. I cruised a 15-acre parcel today. Both of them had root rot. Laminated root rot is widespread throughout Western Washington and Oregon. And in my experience, it tends to show up more on gravelly or pumice soils, not as much on loam, but loam soils can hold the trees upright better. So it doesn't, so there's some symptoms that are sometimes hidden. But it is widespread throughout Western Washington. And any research on susceptibility of nursery transplants versus aerial wind dispersed seeds that sprout on site? Are there tests for Felinus or nursery stock? So the answer in a word is no.
But there should be.
But we could do that, John. We've not tried, let me back up. In our research, we actually asked the nurseries not to apply the normal last potassium application when the seedlings were in the nursery before we bought them, because we wanted to make sure that there would be plenty of opportunity for the seedlings to gobble up that potassium that we applied, if you will. So there's not research on that, John, but somebody certainly could take that on. The problem with research like this, you can see in 10 years, we have a trend. Dan Umdahl would like to see a 95% probability and a 10% confidence limit on the research results, which is outside or above operational forestry. But it was our hope that the Lincoln Tree Farm site and perhaps another site to be followed up with would provide us with replications of the research that we began at Green River. So it just takes a long time, and you've got to be able to replicate everything. Any other questions? I'm not seeing any.
You know, Dick and Paula, John Page here. I serve as the director for career and technical education with Tacoma Public Schools. I did want to just extend a thank you to Dick and Paula, not only for this research and presentation, but the work that you lead at the Lincoln Tree Farm for small woodlot owners, and your contribution to the knowledge base of the forest industry. So I don't get often enough time to thank you for the service that you provide to the school district. I will turn my camera off, but I did want to, I've got so many questions. You always prime to pump for more questions, but I was wondering the spread of Felinus. If it's on a site, if it's in the soil, can it be spread then by harvest equipment? How, you know, if you're trying to contain it to an area or quarantine it to an area, is that even possible, or is it, how does it get spread naturally? Is it just by wind and spores, or do insects carry it, or how does that work?
It is a fungus, so it can spread by spores, but it doesn't. It spreads by root to root contact underground, and it's not in the soil at all. Once you pull infected root systems up and expose it to the air, the Felinus dies. So that's why stumping is so effective. If you can get the stumps out of the ground without leaving too many little lateral roots or whatever in the soil, you've accomplished a survival regime for your next crop, and you can replant with Douglas-fir, as in the last slide I showed on the champion ground. Anything else?
Has there been any research done, or have we gotten anywhere with maybe inoculating trees or like vaccinating trees or anything in that realm?
There's been some study, I think in Idaho and I think in British Columbia. Some of the early work that I did with Champion at Kiona, we were trying a different technique to recent cut stumps, which didn't have any effect on the root rot. So there have been other trials, yes. Nothing has nothing's been fully successful.
Thank you.
Yep.